Hello everyone, myself Srivalli, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. Today we are going to discuss the principle of inclusion exclusion, and also we are going to discuss about the problems on principle on inclusion and exclusion. So here first let us understand what is meant by principle of inclusion and exclusion, then we'll go for the problem solving. So here let A1 and A2 be two sets. Let us suppose here we are considering two sets A1 and A2. Let T1 be the task of choosing an element from A1. So from the A1 set we are taking that T1 is nothing but it is a task of choosing one element from the A1. And T2 be the task of choosing another element from A2. So here there are n of A1 ways to do task T1, n of A2 ways to do task 2. So the number of ways to do either task T1 or T2 is n of A1 union A2 is equal to n of A1 plus n of A2 minus n of A1 intersection A2. So here what is meant by this principle of inclusion is, so if you observe this formula here, so we have seen in the previous earlier classes also, this is principle of inclusion and exclusion, which is nothing but we are going to deal with the union and intersection. So n of A1 union A2 is equal to, or else you can consider this as A union B also. So in the earlier classes, like we have seen n of A union B is equal to n of A plus n of B minus n of A intersection B. So in the same way here, instead of B here we are considering A2. So now if we observe here, we are adding the two tasks and we are subtracting again the common which are there in that two tasks. So here let us suppose we have a task of T1. Let's suppose that a task can be done in n1 ways. Let us suppose a task can be done in n1 ways or a1 ways, and another task can be done in a2 ways. So, but that sum of the set of n1 ways to do the task is, here we can say that n of a1 ways and n of a2 ways. So now if we observe here, so in this situation here, we have to take n of a1 ways and also we have to take n of a2 ways. So if you are considering n of a1 ways and if you are considering n of a2 ways also, definitely it will be counted more. So means it will be counted twice. So instead of counting this twice, what we are doing is, we are counting the number of ways to do the task here, and we are adding the number of ways to do other ways also, and we are subtracting from both a1 and a2 ways which are counted twice, so that you can get the exactly to do correctly here. What we are doing is, first we are adding the number of ways to do the task and we are adding the other ways also to do the task, and we are just subtracting the ways which are common in both, which are counted earlier. So if you do this, then you'll get the exact answer. So this is nothing but here principle of inclusion exclusion. So n of a1 union a2 is equal to n of a1 plus n of a2 minus n of a1 intersection a2. Now here what is this n of a1 intersection a2 is the number of ways to do either task t1 or t2. So and this is either, which is nothing but either it can be done task t1 or t2. Now n of a1 intersection a2 is, that is the number of ways to do both the tasks t1 and 2 at a time here. So the number of ways to do both these tasks t1 and t2. Now theorem here is, so we have the formula, we have the theorem also from this. If A and B are two subsets of some universe set U, then A union B is equal to A plus B minus A intersection B. So this is one theorem if you have only two subsets in this, and we have another theorem also if you have three subsets, which are nothing but finite sets we can call. So here A union B union C is equal to A plus B plus C minus A intersection B minus B intersection C minus C intersection A plus A intersection B intersection C. So let us suppose if you have three subsets and you are going to take this formula, you are going to use this formula. In most of this principle of inclusion exclusion cases, here mostly we will use the second formula only, means with three subsets. So now let us try to solve the problems based on this principle of inclusion and exclusion. So here the question is here, first question, out of 200 students, 50 take maths, 140 take economics and 24 take both. How many of those does not took any of the course? So here, if you observe this question, so here total number of students, is equal to 200. Now here, out of this 200 students, 50 take, means for example, let n of m is, let n of m be the students who take maths. And next here, let n of e be the students who take economics. So here, let n of m, so let n of m intersection e be the students who take both. So here, if you write like this, so that you can understand what is n of m, what is n of e, and also n of m intersection e. So now if you observe here, given n of m is equal to 50 and n of e is equal to 140 and n of m intersection e is equal to 24. Now the question is here, how many of those does not took any of the codes? So here if you observe here, if you go for the formula n of m union e, it is equal to n of m plus n of e minus n of m intersection e. So here if we observe, this union is nothing but who took either maths or economics, and this is intersection e is nothing but who does not here, who are taking both, means the common here. So those who are taking both economics and maths, we can take n of m intersection e. Now if you substitute these values here, as we know that n of m is 50 plus n of e is 140 here, and here n of m intersection e is 24. So now here if you observe here, total 190 we have, 190 minus 24. So what is the answer is here? So 166. So here 190 minus 20 is here 170 minus 4, 166. So now this is the students who took either maths or economics. This total count is 166 is those who took either maths or economics course. But the thing is, the question here we have given is, how many of those does not took any of the course? Means here out of the total, as we know that total number of students are 200, and we know that the students, those who are taken maths and economics, maths or economics course, 166. So if we subtract this 166 students from 200, then we will get here 34 students. And these 34 students does not took any of the course. So this is like how you have to solve the problem for this question here. So and also we'll see the next problem here. In a survey of usage of the 3 toothpaste, like let us consider the toothpaste names are ABC, it is found that 60 people like A and 55 like B, so 55 like B, 40 like C, 20 like A and B, and also 35 like B and C, 15 like A and C, 10 like all the toothpaste, like which is nothing but ABC. Now find the number of persons included in the survey. So we have to find out here the number of persons who are included in the survey. So who are included means they can either choose A or B or C, or they can also choose all. So the question here is, you have to find out how many number of persons they have included in this particular survey. Now let us suppose here, so what we can write here, n of A is equal to, as we have given the question that they have given only ABC toothpaste, so n of A is equal to, so 60 people like A, so we can write n of A. Next, n of B is equal to 55 and n of C is equal to 40. So here 65, 60, 55 and 40. So now, and also we have other problems also, means here you have to write n of A intersection B, as we have given in the question that 20 like A and B. So commonly they will be, they are going to like here 20, which is nothing but here common. So you have to apply the intersection here. N of A intersection B is equal to 20. In the same way here, N of B intersection C is equal to 35. N of A intersection C is equal to 15. So, and also we have another one, 10 like all. So like all means what here? Commonly they are like 10 people. So which is nothing but here N of A intersection B intersection C is equal to 10. Now the question here is all included in the survey. So including in the survey is nothing but you have to write union. So N of A union B union C is equal to question mark, as we need to find out that. So now we know that from the formula here. So in the very first slide we have seen, whenever you have three subsets here, the formula is here A union B union C is equal to A plus B plus C minus A intersection B, B intersection C minus C intersection A plus A intersection B intersection C. So the same formula you have to apply here. So N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C. So now here 60 plus 55 plus 40. Next minus 20, minus 35, minus 15 and plus 10. So here if you observe, so 60 plus 55 here, so 115 plus 40 plus 10, 50. Now here is 50 minus 20, 70. So 115 here, which is nothing but 165 minus 70, which is nothing but here, total you will get 95. So here if we observe here, the answer is 95 people, 95 persons they have included in the survey. So out of this, as we know that here 50 like, so 60 are liking the A and 50 are liking here B, 40 are liking C. Now, but if you take commonly here, total how many persons are included? Means here we are not supposed to count here the people which are they are going to like both. So if at all if you are getting here, you have to do minus. That is what we have done using the formula here. So now the persons who are included in the survey. So this is the answer 95. Now let us go to the third one. Suppose that 200 faculty members can speak French, 50 can speak Russian, while only 20 can speak both French and Russian. So how many faculty members can speak either French or Russian? So now here for example, so as we know that 200 faculty members can speak French here. First of all, you need to assign here. So the set of the faculty here, let us suppose set of faculty. So this is like given you have to write set of faculty who can speak French. Set of faculty who can speak French is equal to N of F. And set of faculty who can speak Russian is equal to N of R. So here we can write that here N of F is equal to 200 and N of R is equal to 50. Now we also have 20 people who can speak both French and Russian. So now you can write here set of people or faculty, you can write it here as we have written in the first itself. Set of faculty who can speak both French and Russian. So which is nothing but N of F intersection R. So which is equal to N of F intersection R is equal to here 20. Now the question is here, how many members can speak either? So wherever you suggest here either here, that is nothing but you have to observe that that is nothing but union formula. So here N of F intersection First, you have to write F union R, because we have to find out the persons, the faculty who can speak either French or Russian. So obviously it is considered as union here. So N of F plus N of R minus N of F intersection R. So here, what is N of F here? 200. And what is N of R? So here N of R is 50 and minus 20. So 250 minus 20, which is nothing but here 230. And these are the persons who can speak either French or Russian here. So now the question here is 230 members they can speak. For example, let us suppose I have total 500 faculty members. Now the question is here, find out how many people, how many faculty can neither speak French nor Russian. Now, what you can do is the question here, from the question. So, as you know, the total 500 members are there, and from that, if you subtract the people who can speak either French or Russian, which is nothing but 230, then the leftover faculty we can consider it as the people who can speak neither French nor Russian. So, this is like how you have to use this formula, principle of inclusion. So, for any type of problems. So, next we also have another example. If there are 200 faculty members who can speak French, 50 that speak Russian and 100 that speak Spanish. So, what is the difference from the previous question to here is, so only we have included the people who can speak Spanish also. So, this is like practice problems, you can solve it here. So, this is very easy to solve also if you understand the question. Next, 20 can speak French and Russian, 60 can speak French and Spanish, 35 can speak Russian and Spanish, and while only 10 people will speak French, Russian and Spanish. Now, how many speak either? So, either means you have to find out the union. So, here, directly here I am writing here, so N of F. So, this first, French is nothing but F, no? So, N of F, Russian is N of R, and Spanish N of S here. Now, here, N of F is equal to 200, N of R is equal to 50, N of S is equal to 100. Now, also we have the other N of 20 members, which is nothing but 20 people will speak French and Russian. So, F and R is equal to 20, and N of F and S will speak 60, and N of R and S is equal to 35. And here we have F intersection R intersection S is equal to 10. So, here you need to solve it here. N of F union R union S is equal to. So, you need to substitute here. So, N of F, which is nothing but 200. So, first we'll write the formula so that you can easily understand. N of F plus N of R plus N of S minus N of F intersection R minus N F intersection R and minus N F intersection S minus N R intersection S. So, here plus N F intersection R intersection S. So, directly substitute these values here, 200 plus 50 plus 100 minus 20 minus 60 minus 35 plus 10 here. So, here 350 plus 10, 360 you will get here. So, as we know that here 200, here 50, 250, 350 and 360 here minus 80 and 115 here. So, what is the answer here? You will get is 360 minus 5 here. What you will write? 355 and one more 345. So, 245 you will get. So, the number of faculty members who can speak either French or Russian or Spanish, which is nothing but here N of F union R union S is equal to 245 members. So, in the same way here we have another question also. A certain computer center employ 100 computer programmers. So, here let us see the question. A certain computer center employs total 300 computer programmers. Out of this, 47 can program in Fortran and 35 in Pascal and 23 can program in both the languages. So now if you represent here in the figure here, so this is like the who can program in Fortran and who can program in Pascal. Now total altogether we have 100. Out of this 100, only 47 can program in Fortran. So 47 can program in Fortran means what? Combinedly you will get here 47 and combinedly you can get here 35. Why? Because 35 can program in Pascal. So now here the question here is, how many can program in neither of the two languages? So neither of the two languages means what here? First you have to take this what we can say, the set of programmers who can program in Fortran is equal to 47 set of programmers who can program in Pascal is equal to 35. So now here total 100 programmers are there. So now 47 plus 35, what you will get here? So 70, 80 you will get. So 47, 70 and what is this? 47, no? So here, so what you will get is 47 plus 5, 52 and 82 you will get. So these are the members who can program in both the languages. So which is nothing but here they are counting. So 47 plus 35 total 82 members. How many can program in neither of these two languages? So neither of the two languages is nothing but here. So what you will get here is 100 minus 82, what you will get here? So obviously 18 members. So the people who are not programming in either of the two languages, we can say here this is 18. So next we also have another question. In the previous example, who can program in only one of the two languages? How many can program in Pascal but not in Fortran? And how many can program in Fortran but not in Pascal? So the same thing you can write it here. So this is like the figure here. So if you are getting 47 means, which is included. And here this is 35. So which is nothing but you can take it as here 24. So here we can say that here 47 and 35. So 37 and 45, which is nothing but here. So we can say that how many can program in only one of the two languages? So one of the two languages is nothing but here. So 24 plus what we can write here is 24 plus 12, which is nothing but 36. Which is nothing but here you are going to take 24 and this is 12. So here 12 means, so 24 plus 12, 36 members who can program in only one of the two languages. How many can program in Pascal but not in Fortran here? So here how many programs can program in only Fortran means what here? So that is 23 members. So why? Because here you need to get here 35. So here you need to get here. So let me write here. So this is 47, this is 35. So we can say that here, so 23, this is 23 common and this is 24. So 24 plus 3 is 27 and 23 plus 12 is 35. So the how many can program in Pascal but not Fortran? So which is nothing but here 24 plus 23, so 27, have 47. And how many can program in Fortran but not in Pascal? So which is nothing but here, so but not in Pascal. This is Fortran and this is Pascal here. So the question here is, the answer what you can write here is, so yeah, how many can program in only one of the two languages is, answer is 24 plus 23, which is nothing but 47. And here, how many can program in Pascal but not in Fortran? So here, but not in Fortran means here 12 members. And how many can program in Fortran but not Pascal here? So here you can consider this answer is here 24 and this is 12. So this is like how you have to solve here. So from the previous question only, this is the sixth question we have continued here. So we also have here, the next one is seventh one. So out of the integers 1 to 1000, how many of them are not divisible by 3, nor by 5, nor by 7? So here let us suppose here what I am doing is, let A be the set of integers. Let us suppose here I am taking, let A be the set of integers from 1 to, let A be the set of integers from 1 to 1000 divisible by 3. And another one, B be the set of integers from 1 to 1000 divisible by 5. So C be the set of integers so from 1 to 1000 divisible by 7. So now if you observe here, A is equal to, so 1000 by 3 and mod B is equal to 1000 by 5, mod C is equal to 1000 by 7. Now here, how many of them are not divisible by 3 nor 5 nor by 7? So which is nothing but here, if you take A union B union C is equal to mod A plus mod B. So here mod B plus mod C minus, so here you need to find out here A intersection B also, as we have 3 here. So first find out here what is A intersection B. So A intersection B is 1000 by 3 into 5 and A intersection C 1000 by 3 into 7 and also B intersection C is equal to 1000 by 5 into 7. So now if you observe here, you will get here 333 and here you will get here 200 and here you will get some what we can say 7 ones are 7 here. So next we have 3, 7 fours are, so 7 fours, 144 roughly you can take as we are taking mod. So now here, so 5, so 200 by 3 here. So let's suppose here I am taking 3 6 are 18 and we also 66 we are taking, 66 roughly we are taking. So and A intersection C here, so we can also take here 7 ones are, so same thing here 144. So 144 by 3, 3 fours are 12 and 3 8s are 24. So here in the same way 5 2s 0, 200 by 7, 7 2s are 14, 6, 7 8s are 28. So the same thing here, A intersection B minus A intersection C minus B intersection C plus A intersection B intersection C. So the thing is here you have to find out N of A intersection B intersection C also, which is nothing but 1000 by 3 into 5 into 7. So whatever the answer you are getting here, some 60 or something if you are getting here, so you need to substitute all here, which is nothing but 333 and 200 plus 144 minus N of A intersection B is what? 66 plus N of A intersection is 28. So here you have to do minus 28 and minus B intersection C here is 28 and whatever the answer you are getting here, so what is nothing but here, for example here 20. So the same thing, the final answer is the conclusion for this question. So this is like here, whenever you got the question, even for the positive integers or any integers here, so you have to consider ABC and you have to divide it and you have to get the answer. So this is like what we have discussed today in this session is what is meant by principle of inclusion exclusion and how to solve the problems on this principle of inclusion exclusion. We have seen few examples on this. So by this, today we'll end the session. Thank you.